Okay, so I will just give you everything. So if you don't have your book, that is absolutely fine, but I want to go over this equation and I will record this so we can start there, and I'll do some more problems so we can have that for review. Okay, so these are drip factor problems. Sorry. So these are drip factors. It's important to know that GTT means drip. So why we're doing this is sometimes you're not going to have an IV pump. You're going to need to calculate how many mLs per hour a patient is getting, and you won't be able to rely on a computer to do it. You're going to have to count something. You're going to have to count these things called drops. So in the ER, we hang a lot of fluids by gravity. So we don't rely on IV pumps. We just give the IV fluids. But you can't just give IV fluids. You've got to do it at a certain rate typically. So I'll have my mLs up here, and I need to give it over a certain amount of hours or a certain amount of minutes. So the way I can figure that out, instead of just, hanging this and giving it to my patient and walking away, is I'm going to count these drops. So this is a drip chamber. And I count the amount of drops and I time it. So I count the amount of drops per minute, which is where this comes in, right there. I count the amount of drips per minute, and that is going to tell me how many mLs per hour I'm giving the patient. So I'm counting how many mLs. So I sit there and I count for an entire minute how many drops are happening in this drop chamber over 1 minute. And I can adjust if I want it to go slower or faster based on the rate I'm giving. So you will be provided IV tubing. So that IV tubing is basically the drip chamber and your IV. So it comes in this nice package, and on the package, it will say something like 10 drops per ml. So this drop factor value over here, you're getting from your package, your packaging. That specific tubing has a specific drop factor that goes with it. So that's where you're getting that value in blue. So let me write down an example problem for you here, and we can talk through it. So let's say our problem, and so this is an order we have in our medication administration record. Someone has written this order. It's D5W to infuse at 100 mLs per hour. Our drop factor is 10 drops per ml. We need to figure out what drops per minute. So it says, what drop per minute should the IV be regulated at? Okay, so this is our problem. This is a problem you're going to have on the quiz. So our goal here is to figure out drops per minute. This is what we're trying to figure out. So this is what the question's asking us. So we're going to plug in some stuff to this equation, and we're going to answer this. So we'll figure out drops per minute. So we'll figure out this value in pink. Okay, so the first thing, we've got to figure out our amount of solution, and this is in mLs. So within this problem, D5W to infuse at 100 mLs per hour with a drop factor of 10 drops per ml, what is the amount of solution in that problem? Do you guys see anything that's marked with ml? What is the amount of solution you think you're going to give? You guys are absolutely correct. So we find, sorry guys, we find 100 ml in this problem. So I'm just figuring the amount of solution in mLs. So in my equation, I have 100 mLs. So I found that. Next, I need to find my drop factor. So this is something that's going to be marked GTT per ml, and that's going to be provided in your problem. So what is given in this problem? D5W to infuse at 100 mLs per hour with a drop factor of 10 drops per ml. So what's our drop factor here? So it's going to be something that's GTT per ml within this problem. Good job, guys. So 10 GTT per ml. So I'm going to write this here. This is my drop factor, 10 GTT per ml. All right, this next one's kind of tricky to find, but we need to figure out time in minutes. So is there anything in that problem that is a unit of time? So D5W to infuse at 100 ml per hour with a drop factor of 10 drops per ml. Is there anything in there that is time? Okay, a lot of you are saying 60, which is very good. So it is 60 minutes, and let me tell you how we got that. So the problem in it says an hour. So we're going to give 100 mLs in 1 hour. And I know 1 hour equals 60 minutes. So that's where I'm going to put 60 minutes. So now we're just going to calculate the problem. So you can get out your calculator or your phone or what have you. And so we can type in 100. So I'm just typing in this equation, 100 times 10. And I divide that by 60. What is that giving you? I divide it by 60. So what is our answer? Let's see here. So I am getting, so my calculator says 16.666 repeating. But a lot of you are saying 17 drops per minute. Very good. So the reason we do that is because you cannot have a partial drop. It needs to be a whole number. So I can't count a 0.66 of a drop, and neither can you. So we are going to round that up, and that's going to give us 17 drops per minute. So 17 drops per minute is what we're going to get there. Okay, so let's do another example here. And I'll keep that equation up and we'll stick with these colors. Hopefully it's helpful to understand. So we're figuring out so that my order for that is 100 mLs per hour. And I need to give 100 mLs per hour, but I can't program 100 mLs. I have to rely on counting those drips to figure out how I can give 100 mLs per hour. So in that equation, I'm going to count 17 drops per minute, and that is going to give me how my 100 mLs per hour. So let me erase this. Let me write this problem. Okay, so let's go to 549. So we're on 549, and let's do practice problem 12. So I'm going to write it out here for those of you who do not have a textbook. in front of you. Okay, so 12 says administer. So you're going to have everything in your textbook or in your problem on the quiz that you need. So administer D5RL at 75 ml per hour. The drop factor is 10 drops per ml. And it's asking you to calculate the flow rate. So calculate GTT per minute. So here we go. So what is the amount of solution in mLs? What in that problem says mLs? So where is it in this problem that it says mLs? That's going to be the first part of our equation. Very good. So this is on 549. 549, page 12. So we're going to administer D5RL at 75 mLs per hour. The drop factor is 10 drops per ml. What is the drop per minute? So we have 75 mLs here, and that is our amount of solution. So we just found that in the problem, and we're pulling it down. Now, what is our drop factor, GTT per ml? What says GTT per ml in this problem? That's going to be our drop factor. So administer D5RL at 75 mLs per hour. The drop factor is 10 drops per ml. So it's 10 drops per ml. So I'm going to write 10 GTT per ml here. And next I'm going to have to figure out time. So is there anything in this problem that's a unit of time? So we have 1 hour here. And remember, if it's an hour, I'm going to write 60 minutes. So I found in my problem a unit of time, which is 1 hour, and I convert that to 60 minutes. So now I get my calculator and I type in 75 times 10. My calculator died, so I type in 75 times 10, and then I divide that by 60. And what does that give us? So I take my calculator and I take 75 times 10 and divide it by 60. And I am getting 12.5. Now remember, you cannot have a partial drop. You need to round to the nearest whole number. So if it's 0.5 or more, we go up. If it's 0.49 or below, we go down. So 2.5, we're going to round up, and that gives us 13 drops per minute. So I'm going to sit there and I'm going to count 13 drops in 1 minute, and that's how I know I'm giving the patient 75 mLs per hour. Okay, absolutely. We can do question 13 real quick. So question 13 in the book says a micro drop. So if you see anything that says micro drop, and you will not have this on your quiz, but a micro drop is 60. Oh, question 15. Absolutely, I can do question 15. But if it says micro drop, it is going to be 60 drops per minute. So if you see that within any of your practice problems, that's what it will be.